talk about the fact that they're not in too many details. One of the things that Trish said that I thought I just can't let it go, and that's the idea of teaching project management is going backwards. And I'm just gonna change that up a little bit. There are some amazing tools that come out of traditional project management that I think as agile practitioners that we maybe don't take enough advantage of, and that we sometimes have thrown everything out because, ooh, we can't do that. RACI charts, bad. Maybe not. Maybe they have a place in time. Weighted factor scoring models, maybe they have a place too. Gantt charts, what a fantastic way to get a conversation going. We're going to talk a lot about conversations tonight, so let's not necessarily throw everything out. But this idea of deterministic planning is certainly something that we're going to talk a little bit about tonight as well. At any point during the course of the evening, if you have questions, if you have comments, if you have thoughts, most importantly, if you have any compliments, please feel free to share them at any time. Very good. That was a good example. Anyone else want to comment on something? Nice shorts. Thank you. Excellent. This is good. You're getting the hang of it. We're liking this. Very good. So let's start off. We're going to break up the evening a little bit. We're going to start talking about estimation, and then we're going to go into talking about forecasting in the second half of this. So we are going to break it into two distinct parts because I believe they serve two very different purposes. Let me start off with estimations here. I have a little bit of a game that I thought we could play right now. We are in a building. This building is 180 Simcoe Street. I would like you, please, to estimate how complicated this building is. How tall is this building? How difficult? Let's just do tall. Tall is easy. We're in the building. This is really a simple question. I'd like you to estimate, please, in feet, how tall this building is. I'll take meters. Nobody want to guess? 26.5 meters. How many? 26.5. That's a very, very accurate or precise type of estimation. 100 feet. Yeah, it could be. Interesting thing is, we really have no idea. And here's the bad news, is that we absolutely suck at estimation. As humans, we suck at it. It could be 100 feet, this building. We have absolutely no idea. What we are good at, though, and as humans, we have an amazing compensating mechanism. Well, we absolutely suck at estimation. We are amazing at comparisons. For example, which building is taller? The building we're in right now or the CN Tower? CN Tower. That didn't take too much effort. So the good news is we are great at making comparisons. Now, is the CN Tower twice as tall or maybe 4 times as tall? Anyone want to guess? More than 10 times, right. So we've got an idea. We've got a magnitude that we can very quickly go, hey, we've got an idea. Now, maybe this is unfair. Maybe this is unfair. This is a building that we're familiar with because we're in it right now. And the CN Tower is just down the street from us right here. Maybe that's an unfair comparison. Let me bring in 2 other buildings. There's the Chateau Frontenac in Quebec City. And there's Bolt Castle, which is actually in the US, in the Thousand Islands, just off of Gananoque. Which out of these buildings do you think is the tallest? The one in the top, the Chateau Frontenac? But how do you know? You can't even see half of Bolt Castle. It's covered by trees. Exactly. It's actually taller than you probably think it is. It's actually 6 stories tall, which is pretty impressive for a building that's covered by trees. But the amazing thing is that without a lot of knowledge, we are really good at comparing things. We're really good at it. We've all just done it. We've all proven it. We've all shown that we can do it. So when we talk about estimation, before we get into actually doing some estimation, I would love to know from your experience, why might we need to estimate? What are some reasons we might need to do it that you've needed to in the past? To come to a ballpark, I'm just going to repeat it because I have a microphone and you don't, and that way everyone can hear me. So if I repeat you, it's just because I have a microphone. Not that I'm proud of that fact at all, but I have a microphone. But the answer over here, which I'll repeat because I have a microphone, is that is that we might need to do some estimation because we have to figure out when a piece of work can get done. Okay, that is absolutely a reason we might be asked to estimate. I've got a fun story about that one. I'll come back to that one in a minute. What else? Any other reasons? Yes? It might affect other decisions. Like what? Like what? Whether I should wear shorts or pants? It could, right? I might estimate the temperature. Yeah, anyway. Anything else? Get approval for a project. Right. So how would an estimate impact whether or not I get an approval for a project? Cost. Right. Does it meet an internal hurdle rate or an internal rate of return? By the way, hurdle rates and internal rates of return, project management terms. Just put that out there. But yeah, right, absolutely. Hurdle rates and internal rates of return are still absolutely important for us. We need to know what our return on investment is going to be. Does the investment justify us doing it? Are we going to make money on it? So there's a few reasons that we're going to estimate. There's another reason that we didn't mention here. Oh, yeah? Because our leaders, what do our leaders want to know? Why are our leaders asking us? Is that the question? We don't know, but they ask us? Our leaders have told us we need an estimate on this. Let me tell you a funny story, and it kind of comes back to this, when are we going to want to do it? Sorry, I got two things. When do we want to do it? And our leaders are asking for it. Let me do that one. And the other one is a third reason I think that we estimate things, and that's that we want to come up to a shared understanding on how we're going to do something. We want to get ideas as to whether you think this is risky or I think this is risky or how we might approach the work. And I'll come back to that one in a second because we're not actually going to talk about this first one. The first one is, are we going to get to which project should we work on? That's not the type of estimation we're going to talk about tonight. Invite me back and I'll talk about that another time. Tonight we're going to actually talk about, we've actually decided to do a piece of work and now we're sitting down and we're looking at individual product backlog items or user stories or work breakdown structure items, and we're trying to estimate those. But let me give you a quick story. I was debating whether or not to tell this story, and I decided, thanks to both of your comments, that I will. This is a true story that happened to me at a large banking financial institution in Canada. This happens to be an international bank. They have a huge footprint in the US, lots in the UK, and a little bit here in Canada. And here we are in Canada. And the folks said, we have this idea for this whiz-bang idea. We think we should do this thing, but we're concerned about how long it's going to take. And so I said, okay, no problem. I got the development team into the room and I said, guys, here's the feature that they want to build. Here's the problem that they want to solve for the customers. Here's the things that they think is going to make a big difference for it. And the team kind of said, oh, okay, we get it. We know what the problem is. We understand what it is. And I asked them, have you done this before? They said, no. I said, okay, well then, I'd just like to get a ballpark. Do you think we could probably get this done in about a month? They laughed. They said, no, we can't do this in a month. I said, cool. What about 12 months? And they said, yeah, obviously we could do this if we had a year. I said, cool. What about 6 months? Yeah, maybe, probably. I think we could probably do it in 6 months. Yeah, I'm going to say yes. Team, 6 developers on the team, 1 tester. They said, yeah, you know what? We think we can do this in 6 months. I said, cool. What about 3 months? And they went, not likely. I said, so what, like 20% likely? And they said, maybe at best case, very unlikely. I said, okay, so we're sort of in that 3 to 6 month range. Do you think you could do this? They said, yes. I said, cool. I said, so like, would you say 4 months? Well, not sure. 5 months? Probably. Okay, 5 months. Does that seem like a reasonable amount of time for this? Yeah, 5 months, maybe 6, but 5 months, we're probably in around there. I said, cool, that's good. I looked at my watch, 7.5 minutes. I said, well, this meeting was booked for half an hour. We've used 7.5 minutes. Anything else you need? Senior product manager person who's trying to decide whether we're going to do this? He said, that's not a good enough estimation. That's not an acceptable way to estimate. You need to do more analysis. I said, no, we don't. We got a pretty good idea. It's going to be about 5 months, maybe 6. But in about that rate. No, we need more analysis. We need to do documentation and analysis. And I said, I'm not sure we do. I mean, I guess we could, or we could just start working on it. And if we learn something new, we'll certainly let you know that's a problem. He said, well, I don't like this. I said, I don't care. I said, do you want us to get going? he said, fine, but you could tell he was so uncomfortable, and he was so uncomfortable with it. Every week, we shared where we were going on with this project. We learned some things as we were going on. We learned that we had a dependency on a team that we had no idea about when we did this estimate. We had no idea we were going to depend on this breath. This team. This team was called the Hog's Breath. They own the API layer at this organization. They were the Hog's Breath. Let me tell you, they were a lot of fun to deal with. The end of the story, though, is remember it took us 7.5 minutes to guess that it was going to be somewhere between 4 to 5, but probably 5 to 6 months. Yeah, it was 4.5 months. We had the thing in production and delivered in 4.5 months. It's incredible how fast our gut is at being able to compare this work compared to other work that we had done in the past. And we were able to, and when I say we, I had absolutely nothing to do with this except that I facilitated the conversation. The development team was able to get a pretty good sense of how long it was going to take to do this work, and they did it in 7.5 minutes. Now, could we have done more analysis? Sure. Would that have made it go any faster? Probably not. The interesting thing about estimating and deciding whether to do something is that it was 4.5 months from when we started. If we had done a month of analysis, it would have been 5.5 months for us to deliver that. Is that the right thing to do or the wrong thing to do? I don't know. It's not my money deciding whether or not to buy this thing. The interesting thing for me is the number of times that we are asked to do estimation of work that we've already decided to do. Someone's already made a decision, you're going to do this thing. And so we often are asked to estimate for reasons that sometimes we don't understand. Once we've decided we're going to do something, though, we can get into figuring out how we're actually going to do that little bit of work. And for that, I'm going to borrow from my friends, the Wiggles. These are the Wiggles, and they sing a fun song about fruit salad. And so we're going to talk about estimating with fruit salad. We are not talking here about the should we do this project versus that project. Like I say, there are ways to do that. We're not doing that. This is probably something you would use at a team level to decide how we're actually going to do something. So stick with me here. We're going to do some things on fruit salad. Here we go. We're going to play a fun game. Another game of comparisons here. I would like you to estimate grapes. We're making a fruit salad and I need you to estimate grapes. How risky, how complex are grapes? How much time are they going to take? What's that? To grow or to eat? Oh, I like that question. Brilliant. Yeah. Growing, very different, right? Where are we starting this fruit salad? Let's assume for the purpose of this fruit salad that we can go to a grocery store, and that let's assume for the moment that this grocery store is relatively well stocked. We don't really know. When we're comparing grapes, we don't know. It's hard to answer the question. It could be a 1. It also could be a 7 if we're comparing grapes versus chocolate chips. Chocolate chips you just pour out of a bag. Now, whether or not chocolate chips go in a fruit salad is another question. But again, compared to what? And so let's do a comparison here. Which one of these is likely easier? Which one is less risky? What makes it less risky? You can see them? Yeah. What else? Fewer people are allergic. Okay. You don't need a knife. Pineapples are filled with spikes. They're dangerous. They can attack you. By the way, there is one food in the world that I despise. It happens to be pineapple. It's the only thing that I despise. So here's what I've got. I've come up with 6 fruits. I did some research on the internet, and I was able to determine what are some delicious fruits. And so what I'd like you to do on the top of your sheet as a table, you can do it on your own if you'd like, or you can join a table, your choice. But as a table, I'd like you to estimate these 6 delicious fruits. Which one is the least risky? Which one is the easiest to do? Think about putting them in some sort of order. I've got 6 delicious fruits. I've got apples, grapes, oranges, tomatoes, pineapples, and bananas. Go ahead and list them in order from easiest to hardest, from simplest to most risky. What? Well, write it down. Write it down. Whatever you think. Tomato is a fruit. Yep. Oh, I'm not kidding. I did my research. What's that?
Which one is least risky? Which one is it? You meant to prepare and put in a salad.
Yeah,
You didn't say.
we're making a fruit salad. I think everybody else got it. Did I turn this? Yeah. All right. Okay. All right, that's about enough time. I think that's enough time. Come on back. Everyone, did I turn this microphone off? Oh, no, it's still on. Okay. All right. So let me get everyone's attention back, if I could. If I can get everyone's attention back. That's enough time for estimation. That's enough time. All right. We're going to stop talking here because we've got to get this project going now. We got to get going. We got to build our fruit salad. Yummy, yummy. It is fruit salad. Okay, so let me start. Let me start with a table on my side over here, on you folks over here. What do you think out of all of these things? Oh, hold on a second. Let me make sure. I want to make sure these guys are going to hear you because they might have a different opinion, and I don't want you to miss out on what these guys are going to say over here. Okay, so tell me what is you think the easiest fruit for us to prepare for our fruit salad. Apples. Excellent. Okay. How about this table in the middle? Do you think apples are the easiest, or did you come up with something different?
We thought apples were second hardest.
You think apples are second hardest? Second most challenging. Okay, that's interesting. That's a very different perception than they have over here. Okay, hold on. Let me go to another table over here. Let me come out to this side here. Let me get one of you guys out here. Can you tell me what do you think is the easiest? Grapes. Where did apples fit for you? Apples were number 3, so grapes, something, apples? Okay, so we've got an interesting divergence of opinions going on here. Estimation is a fantastic way for us to expose some of our thinking and start a conversation. So the next question I'm going to ask is, what makes apples the easiest? Doesn't need to be peeled, okay. Compared to, sorry? Oranges and bananas both need to be peeled. Yeah. Okay. Anything else? Readily available. I like that. Cheaper than grapes. Very, very good. All right. Excellent. And you had apples sort of way more at the end. Why were apples so complicated from your perspective?
We had to wash them as opposed to maybe bananas or oranges where you wouldn't have to wash them.
So we had to wash apples, whereas bananas and oranges don't have to be washed. Did you think about that? Oh, they wash oranges. They wash oranges. Okay. Okay. Well, anything else?
They're also pretty firm, so they're challenging to cut. You have to take out the core, take out the seeds.
Yeah. Yeah. It turns out if you don't do that, people don't like it. I learned that one the hard way. And you had apples somewhere towards the top as well. What?
Number 3, yeah. So maybe it's similar. Like you still have to put it in a fruit salad. You have to cut it. You have to take the core out for sure. So they're not, at least from our perspective, easy.
And you had, I think, grapes as the easiest.
Correct.
Grapes. What made grapes the easiest?
You don't need a knife to cut them. You can just throw them in fairly easily. Just use your finger to take them off the line.
What if?
Fruit salad, and they're off the races.
What if I told you that I wanted my grapes peeled and cut evenly into thirds? Changes things, right? And the interesting about estimation is that no matter what order you put things in on your paper is that you started a conversation as to how you imagined doing the work. How you were going to imagine cutting the firm apples, washing the oranges. I will admit, I have done this many times. No one has ever told me they washed the oranges before. That's really cool. But this is interesting, right? Is that it exposes different thinking that's going on here. And that's one of the big things that we get out of having this estimation. One of the reasons that we have this conversation. The interesting thing is that before we estimate anything, we often jump straight into we jump straight into it. And fair enough, I asked you the question of estimate all of the fruit. By the way, where did tomatoes fit in the not? Yeah. So it's interesting. Before we focus on estimating how we might do something, we first should actually be having a conversation of if we should be doing it or not. And I see this too often happen in teams that I work with where they've been told to do something and never have the conversation to actually think about, should we actually be doing this or not? Tomatoes, yes, are 100% a fruit. Biologically, they are a fruit. Anyone play Dungeons and Dragons? If you do, there are some character stats. I like that a few hands went up. Because intelligence is knowing that a tomato doesn't go in a fruit salad, and charisma is convincing people that yes, it does. Um, but yeah, tomatoes. We don't generally put tomatoes, even though they are a fruit, into a fruit salad. We really only focused on these 5 fruits, hopefully. So Tom absolutely got the answer right, that we probably shouldn't be even estimating tomatoes here, and because we shouldn't be doing it in the first place. It does not go into a fruit salad. Yes, sir.
So I'm not sure about that because we didn't ask who was the fruit salad for.
Beautiful. The fruit salad's for me. I'm going to be serving it to my guests. But yeah. Well, yeah, there's going to be no pineapples in my fruit salad, but it's for my guests. And my guests are weird and they all like pineapple. And by the way, guess which pizza I didn't have any of? And yet other people did, so that's cool. The entire point of having this estimation is for us to come up to that shared understanding. Now, because this is my presentation and my game, I've come up with the right answer. The right answer for these is that grapes are the easiest because I don't need them peeled and cut into thirds. Apples kind of come next because they do require a knife to cut them, as does a banana, which also needs to be peeled. The banana doesn't have the same risk because it doesn't have to be a sharp knife. And so not only am I factoring in the level of effort, but I'm also factoring in the amount of risk that's involved in doing it. In fact, bananas I can probably break up with my hands. Everybody loves it when I touch all of the fruit with my hands before I put it in the fruit salad. I wear gloves, obviously. But then we've got apples. I like the point about oranges needing to, who have ever had oranges, saying we need to peel them. Certainly amount of work there, and there's generally seeds in oranges, so I've got to make sure that I buy the right ones. And then pineapples are by far the riskiest one of these. Now, you may have come up with a different answer, and all I'll say is that was wrong. No. The important thing is that you had a conversation at your table, and the entire idea of doing this sort of estimation work with your team is so that you can come up with that shared understanding and exposing people's thinking of, do we need to wash the oranges? Do I need to cut the bananas a certain way? Do I need to wash the grapes and then wash the oranges and wash the bananas? So all of these things come up through the conversation. It's important for us to realize that that's a conversation just for us on our team. That's just for us at the table. Somebody else might have a different perspective that is equally valid. It's also a chance to clarify requirements or expectations with product owners, maybe stakeholders, maybe users. Imagine that, going out and actually talking to the users. Hey, do you really want pineapple in your fruit salad? No, who would want that? But go out and actually find out these types of things so we can actually expose some of our thinking, and we can better clarify whether we need the grapes cut into thirds or whether we need them just peeled off and thrown in. Now, to help us with this, we often use some sort of scale because it's difficult to say, imagine we wanted some other fruit thrown in here. Imagine we added pears. Well, pears are like an apple. Well, we could, but very often we'll find teams will use some sort of numbering sequence with them. So they might use numbers. Like grapes, as Mara said earlier, grapes are going to be a 1, bananas are a 2, and apples are a 3, oranges are 4, and pineapples are 5. It just helps us create a bucket for us to put these things in. Sometimes people will size them with t-shirt sizes. I love t-shirt sizes because you know why I love t-shirt sizes? You can't do math with t-shirt sizes. And the moment you put a number there, people are going to want to do math with it. We're going to do that in a minute. Don't worry. Foreshadowing. We can do it with base 2. 1, 2, 4, 8, 16, 32. Some of us like to count in twos or by powers of 2, so we can do with base 2. A lot of teams use the Fibonacci sequence where the next number equals the sum of the previous 2. So you've got 1, 2, 3, 5, 8, 13, 21, 34, 55. I don't know where it goes, 80 something. After that, Fibonacci's nice, but you'll notice that all of these are just ways for us to bucket the numbers. The numbers and letters and things that we're doing all mean the same thing. So whether we're using a 4 in our sizing with numbers or we're using a 5 in the Fibonacci sequence, it just means it's sort of this bigger than other thing. My favorite, though, is sizing with gaming dice. Again, going back to my Dungeons and Dragons point, is that gaming dice are really nice. Gaming dice have different sides, different numbers on the dice. So the blue or the purple one there is the one that most of us are most common with. That's a D6. It has the numbers 1 to 6 on it. That's what we use in most of our games. But the orange one down in the bottom is a D4. It has the numbers 1, 2, 3, and 4 on it. That's it. And so the reason that I really like these gaming dice is they remind us that even though we're putting a size to something, is that there's some variability with it. I can put a D6 there, and that means I can sometimes roll a 1, or it means sometimes I'll roll a 6. Sometimes, if I'm using a gaming die, in this case, my D6 happens to be my bananas, sometimes the bananas are going to be mushy, and they're going to require more work, or I'm going to need to throw them out and start over. It also means sometimes they're going to be underripe, and I'm going to have to wait for them in order to get fully ripe. There's some variability in what we're going to do. So I'm a big fan of gaming dice. Also, it's fun because you can give everybody gaming dice and then you can roll them and you can have fun with gaming dice here. But this makes it easy. Whatever scale we use, it makes it easy for us to have a conversation. So I mentioned the idea a moment ago is imagine now we wanted to add a pear into this. Where would a pear fit in this scale? You can just use the numbers 1, 2, 3, 4, or 5. With the tomato, yes. Except you'll notice that there is no tomato on here. So are you suggesting that we shouldn't put pears in a fruit salad? Do pears not go in a fruit salad? It's a great conversation. And maybe they don't. I don't know. Should pears go in the fruit salad? Okay. And if they go in the fruit salad, what number are they? 3. Same as apples. Makes sense. There was general consensus around that. A couple people said 2s. I'd be curious to understand why. What about blueberries? If I wanted to add blueberries to my fruit salad, where would they go? 1. Wow. You guys are fantastic at comparisons. What's that?
Yeah. 0.5.
You know, I did this activity with a team. The comment over here was they're actually easier than grapes. Maybe they should be a 0. I did this activity with a team where we actually did exactly this with what was supposed to be 3 months worth of work. And we actually had each product backlog item written on a board, and we started putting them up on the boards. These were the 1s, these were the 2s, these were the 3s. And then they started to go, well, no, these are easier, so we created a 1, zeros. Then we created a 1.5. Then we created 2.5. And we ended up with, I think, 13 different buckets for this. 13 buckets. No. Like there was something like 80 items in the backlog that we were going to do. It was huge. It was something like 80. We ended up with 13 buckets. And then at the end, after we put them into the 13 buckets, I went up and I said, are the blueberries different enough from the grapes that they deserve their own category? And the team looked at me and said, no, they're actually all about the same. And so we're not interested in whether something's going to take you 5 minutes or 10 minutes. We're interested if something's going to take you a magnitude of effort difference. So you're absolutely 100% right. The blueberries are probably easier than the grapes. Are they easier enough that they are worth giving their own number to? And I don't know the answer to that. There is no right answer to that, except that I'm going to suggest that maybe not, because they're close enough to the grapes that for the intent, for the conversation that we're going to have, they're close enough to grapes, but we've just exposed an idea that, we don't even need to peel them off the stems. Hey, has anyone ever got a pint of blueberries or a quart of blueberries and not every stem has been taken off of it? I have. And so maybe our assumption is, and so what a great conversation, our assumption is that every stem is going to be off the blueberries. We can just take the bucket and dump them in. But maybe someone puts their hand up and says, actually, I've had a few pints of blueberries and we have to pull the stems off of some of them, so maybe we should double check them. Okay, great. Sounds to me like they're similar enough to a grape. But again, we're focused on that magnitude of effort. We're not necessarily focused on the actual number. And so we might actually have an interesting conversation. Should bananas be the same as apples? Or are they the same as oranges? Great conversation. Whoops. Now, if we had pineapples, if we had coconuts, we could probably very quickly say that they are close enough to a pineapple. Somebody might say, actually, they're even harder. We need a machete to open those up. All right, fair enough. Maybe they are a 13, maybe they're an 8. Being that I've never made a fruit salad with either coconuts or pineapples, I honestly don't know the answer to that question, whether pineapples and coconuts are the same. They both seem relatively similar. someone might almost suggest that coconuts probably don't go in a fruit salad. I don't know whether that's true or not. Maybe they're with you and that the coconuts should be with the tomato. I'm not sure. I'm not sure. Like I say, I've never done it. Estimates, doing this estimation, this quick little activity that we've just done right here, is not about getting the right number. It's not. It's not about the number at all. It's about exposing our thinking, the assumptions that we're making, the dependencies that we think about, the challenges that we might have, the risks that are going to be going on. It's making those things explicit. Because on our teams, all of this work is in our head. And I can't imagine what's in your head. So when you say, no problem, I can build a fruit salad, and you say over here, oh, it's very risky, you know, it's going to take a lot of work. And I'm like, what is a fruit salad? Yeah, well, we need to wash every orange. We need to get out a toothbrush and scrub it because we need to, and all of a sudden, there could be validity in that. I have no idea. But we start to expose the thinking. We start to expose why you think something is the way you think it is. So it gets what's implicitly in our minds out of our minds so that we can have a conversation about it. That conversation is way more important than any number or any sort of, whether you're using a number or you're using a small, medium, or large, any of those things. It's about that conversation. And it can really focus on making sure that expectations across the team are aligned. That's really the goal of this. Now, I worked with a team, and they said, Jeff, we need to estimate our work. That's the only way that we can have these conversations. I said, want to try a different way? And they said, okay, but we need to estimate. That's what we have to do. Jira tells us we have to estimate. There's a field here that says estimate, and we have to do it. And our managers tell us we need to estimate all of this work. And I said to the team, I said, you want to try a different way? They said, you're crazy. The only way to do this is estimate. We have to estimate. We have to put a Fibonacci, and it has to be Fibonacci. That's the rule. You can't be agile without Fibonacci. I said, okay, but Jeff, we like you. We'll humor you. What's this crazy, stupid idea you've got? I said, what if we just talked about how we might do the work? Let's just break down the steps that we're going to do. They said, that's stupid. That won't work. I said, all right, well, why don't we just try it this sprint? Why don't we just try it and see what happens? They said, fine, but you're wrong. I said, probably. Wouldn't be the first time. And so what the team did is, instead of worrying about estimates, right in the Jira card itself, they actually started to write down the things they needed to do. Well, we need to update the table. We need to update this database. We need to add this field in. We need to make sure it can hold this many characters. Oh, we need to capture that on the front end. We need to do front end validation to make sure that they're entering it in the right way. It's a phone number, so we need to normalize that. We need to make sure that we strip out all of the spaces and special characters that people put in. We actually want to prevent people from putting in characters that shouldn't be in phone numbers. So let's make sure that, all right, we wrote all of those things out. And I said, cool, let's go on to the next one. And we did that for a sprint. And then we did it for another sprint. And then we did it for another sprint. And the team started to realize that the hard part of software development isn't the typing, it's the thinking. And what they actually realized is that by talking it through as a full team with the shared wisdom of everybody on that team, is they ended up doing a lot of the thinking in that planning meeting. And it meant when they came to actually doing the coding, they'd already done some of the thinking. They'd already thought through, well, oh yeah, I might need to do that, and I might need to do that, and I might need to do that. And it actually made their development go a lot smoother. Their typing became a lot, they needed to type fewer words to do it. Their variables were better named when they did it. They had less code they needed to delete at the end because they were doing the thinking up front, and they weren't doing it on their own or even in a pair. They were doing it collectively with a team of 6 or 7 other developers who were all thinking through the problem together. And they ended up avoiding estimation altogether. Did it take them any longer? No. In fact, it probably went faster for them. And if you were to go and ask them, they'd say, yes, it went faster. We started getting more stuff done because we weren't encountering problems in development. We were thinking about some of those things ahead of time. Now, it doesn't mean they got everything right. In fact, they missed things all of the time. That's the nature of knowledge work, is that we're going to learn things by actually doing it. And they did. They learned things by actually doing it. But it was unbelievably incredible how much faster, how much smoother, how much better things went because they stopped estimating and instead talked about how they were going to do it. A lot of teams, when they get into estimation, will realize that if they just hold up a 3 every time they do estimation, they don't actually have to talk about anything. Oh, look, if we all say 3, we all think it's the same thing. Great, let's go on to the next thing. Oh, look, we're all threes again. Huh, how'd that work out? And so the idea of using estimation to start conversations can work, but it can also have the opposite effect where people don't talk. And the problem is when I think it's a three, I think it's a three for one reason, and you think it's a three for another reason. And John at the back there is putting up a three just because he doesn't want to talk to anyone. Here's the thing about estimation, is that it's about getting everybody on the same page to understanding the problem and understanding how we're going to do it, because you cannot tell time with estimates. And to prove that, I'd like to go on to the second activity on your piece of paper there in your table right now. I have decided that for my fruit salad, I want 50 bunches of grapes, 22 bananas, 18 apples, 12 oranges, and 4 pineapples in my fruit salad. I would like you please tell me, when will my fruit salad be ready for me to serve to my guests? Go. I'm sorry? Can we? No, we've bought them. We've already bought them. Yeah. We've already bought them. All of the fruit is sitting on my counter, just waiting to be prepared for the fruit salad. All right, I'm going to stop you here. I'm going to stop you here because in case you haven't figured it out, you actually can't answer my question. It was a trick question. You cannot answer the question. It is impossible for you to answer the question. 42. That is the only possible answer that could potentially be right. And even in this case, it's not right. So here, let me talk a little bit about fruit salads a little bit before. There's a bunch of ways that we can go about building our fruit salads. For example, we could cut up all of the grapes. Then we could go on and do the oranges, and then we could go up and do the pineapples. We could work in these layers. But what I want you to remember is that we don't have a fruit salad. If we do layer 3 here of those grapes, we actually don't have a fruit salad. We have a bowl of grapes. When we do the grapes and oranges, we don't really have a fruit salad. We have grapes and oranges in a bowl. We don't get the value. We don't get to know if we're building the right thing. We don't get to know that our fruit salad is done until we integrate that all right at the very end. When we bring all of the fruit together and we put it together, that's when we have a fruit salad. And so when I work in these layers, if I work in the grapes and then the oranges and then the apples and then the bananas, I don't have a fruit salad until I get it all done, and then congratulations, it's done. That's not how I want to build a fruit salad. When I build a fruit salad, I'm going to work in vertical layers. I'm going to do a little bit of grapes, a little bit of oranges, a little bit of pineapples, apples, and bananas. I'm going to do a little bit for a period of time. And there's a bunch of reasons that I'm going to do this, but the first one is that I'm actually delivering fruit value much sooner. Now, it's a smaller amount of value, but I'm delivering a little bit of my fruit salad. I could deliver it at the first point here. The other thing is that I want you to remember that we originally had tomatoes in here. Now, imagine we've never built tomatoes, a fruit salad before. We went on the internet and we found out that tomatoes are in fact a fruit. And so we go and we put them in our fruit salad. In the top example, the first opportunity I have to learn that tomatoes should not go in a fruit salad is right at the end when I've integrated everything together. Whereas if I'm building them in vertical slices, these vertical strips, I actually learn that tomatoes don't go in way sooner. So really, when we're looking at this example, when we're looking at this here, my top example is really a late learning strategy. My bottom example is not only am I delivering value sooner, but I'm learning sooner. And in case anyone hasn't figured it out, there are benefits to reducing the risk as well. In my top example here, I don't know if I've got the right ratio of fruits going into this. I don't know if the fruits go together. I don't know if the fruits taste good in the right combination. Maybe it needs more blueberries. Maybe it needs more apples. Maybe it needs less grapes. I have no idea here until the very end. Whereas in the bottom example, I start reducing some of that risk. I start to learn that these elements work together, or these elements go together, or these elements make sense and work in the environment, in the domain that I'm expecting them to work in. And in case you haven't figured it out, I'm not really talking about fruit salad here. Just to make sure that that's true. Now, let's get on to forecasting a little bit. Here's going to be forecasting. We're going to move away from estimation and we're going to move into forecasting a little bit. We've got that estimation is for us as a team to understand, expose risks, thinkings, assumptions, dependencies that we've recognized, all of those types of things. But now we want to get to that question of when will it be done, or when will when do our managers think it's going to get done, or when do we think we're going to be able to deliver this fruit salad? So let me give you a little bit more data that'll probably help. I'm going to work in some iterations here in doing my fruit salad. In my first iteration, I do 6 bunches of grapes, 2 bananas, 2 apples, an orange, and a pineapple. In my second iteration, I work for a few more minutes. I do 5 more bunches of grapes, 2 bananas, 3 apples, a couple of oranges. I'm not going to bother with pineapple because it turns out pineapples produce an awful lot of fruit. And so to balance out that amount of fruit, I actually don't need to do a pineapple in my second iteration. I need more of the other fruit to balance out the huge amounts of pineapple I got from that first pineapple. That was neat learning that I got. I go on and I do a third iteration. I do a couple of grapes, a couple of bananas, apples, oranges, and this time I've realized I'm going to do a bunch of pineapples. I got some feedback that after that second iteration that people want more pineapples, so you know what? Pineapples, it's going to be. I've been working in 10-minute iterations. I've been working for 10 minutes doing each of these things. 10 minutes, 1 week, 1 month. Doesn't matter what time you want, just to make this easier because we're trying to get to this point. I'm going to work in 10-minute iterations. And so in my fruit salad, I want 50 bunches of grapes, 22 bananas, 18 apples, 12 oranges, 4 pineapples. Now you have the data available to you. I would like you, please, in your table, figure out one or more participants are waiting in the lobby. Just thought you should know that. Maybe they want to know when this fruit salad is going to be ready. In your table, let's take a couple of minutes and hold on. Wait, there's more instructions than this. There's more instructions than this. I'd like you to take a few minutes. The time is right now 6:53. Because I don't do 53s, we're going to call it 6:55. At 7:10, I'm going to start talking again. Maybe 7:15. 7:15. That's 20 minutes from now. That's over 20 minutes from now. In that 20 minutes, you have an opportunity at your table to figure out when my fruit salad is going to be ready using this data. You also have a chance to network with each other. If you're interested in jobs, there's going to be people at this back table who are either hiring or firing, and maybe well, they're going to need replacements if that's the case. But if you head back over to this table, if you're either looking for a job or looking to hire, please head back over here behind Nima. And you can, Neem is the fancy looking gentleman over there in the dapper shirt and the dapper tie. I missed the memo. I put on shorts. But if you want to head back there, we can talk about jobs if you're looking to hire or looking to be hired. Otherwise, let's take a few minutes, network, meet some people, grab some more pizza, grab some more drinks, and see if you can answer this question when we come back at 7:15. Ready? Go.
With these three iterations, I'm not covering all of this. Are there more iterations that I need to plan myself?
Yeah, so that's the question. The question is, when is my fruit salad going to be done?
No, but with this, only
Yeah.
3 iterations?
I've only done 3 iterations so far. Based
So
on
they're
that,
already done?
yes, those 3 are done.
Oh, okay.
So based on that,
Yeah.
how much longer to get the rest
Per
of it done?
iteration took you like 10 minutes?
Each iteration took 10 minutes.
Oh.
Did you come up with an answer? What was your answer? Sorry?
30 minutes.
Okay, let's see if you're right. Well done. All right, everyone. Let's come back here and see if we can finish this off. I've not only forecasted how much fruit salad we're going to build. Okay, that's good. Thanks. I was waiting for that. Not only have we forecasted how we're going to do in fruit salad, I've also forecasted how long this meetup's going to last. And we'll see if I'm right. So, I know one table has completed the activity and came up with an answer. Did anybody else? One table over here came up with it. You guys did it as well? All right. Let's go to anyone else? Anyone else? All right. Let's have a look. When is my fruit salad going to be ready to serve to my guests? 80 minutes from now. When is my fruit salad going to be ready to serve to my guests? Between 60 and 90 minutes. When is my fruit salad going to be ready? Between 70 and 80 minutes. So you're all in the ballpark. For those of you who didn't do it, here's one way that you can do it, and then I'm going to show you why this way is wrong. Let me go back to my way of scoring these things. This is a typical way that most teams do these forecasty things, and I'm going to show you why we don't need to do this. It's my game, so I'm going to use the Fibonacci sequence because many teams use Fibonacci. So I'm going to use 1, 2, 3, 5, and 8 for these. In my fruit salad, I wanted 50 bunches of grapes, 22 bananas. You don't need me to read this to you. So I'm going to figure out what my total scope is. My total scope is that I want 50 bunches of grapes at 1 point each is 50 points. 2 points for 22 bananas is 44 points. That gives me a total of 240 points. In order to calculate this out, we look at how many fruits I cut up in the first iteration. 6 grapes, 2 bananas, 2 apples, 1 orange, 1 pineapple. We take the number of points per item and we multiply this out. So in my first iteration, I did 29 fruit points. Everyone with me so far? In my second iteration, I did 28 fruit points. And in my third iteration, I did 35 fruit points. I'm on fire in my third iteration. Whew. So my total so far is that I've done 92 fruit points, and it's taken me 30 minutes to do that. So roughly 10 minutes for 30 points. So the question is, when will I complete 240 points of fruit? The answer is that it's already taken me 3 iterations to complete 92 points of fruit. So the important thing to remember here, and there was a question that was raised earlier during the break, and it's like, Jeff, what exactly were we supposed to be doing here? We weren't listening. No, that's not the question they asked. But the question is that with this data, we actually now have the ability to forecast. We can't do it without data. Very often we are asked, when is something going to be done? And we do that, going back to our traditional project management methodology, if we follow PMBOK, in our initiating and planning phases, we are asked to estimate something and we have no baseline to know how fast or what the capacity or throughput of our team is. So we say 42, because we don't know how it's going to go. In this case, we have 3 sprints worth of data, and it's that data that enables us to actually have this conversation. So we've got 3 iterations to complete 92 pieces of fruit. The total points divided by the average throughput is the expected amount of time. So in this case, 240 divided by 30 equals 8, maybe 9 iterations, somewhere between 80 to 90 minutes in total. But remember, I've already done 30 minutes of work, so we can subtract that off. But my total scope in order to complete this is exactly that, 80 to 90 minutes, less the 30 I've already done. Now, this is a convoluted way to do it. I had to multiply fruits by points, and I'm like, what a stupid. Seriously, people will do stupid things with numbers because you can do math with numbers. There is absolutely no reason to do it that goofy way that we did with story points and multiplication. What we can do is just count the pieces of fruit that we've completed. Some people are going to argue about this, and I'll tell you what they're going to argue about in a second. But here we go. I was completing roughly 12 pieces of fruit per sprint, per iteration. There are 106 pieces of fruit. Total fruit divided by the average completed, 106 divided by 12, gives me actually 8.8, which is still in that 80 to 90 minute range. I don't need to do stupid math in order to figure this out. I can just count the number of things that I've done. Now, some people, oh, there we go, 10 minutes per iteration, roughly 80 to 90 minutes. Some people argue, yeah, but Jeff, some of these items are big and some of these items are small. For that, I will refer you to the great work of Deming and variation in a system. Every system has variation. Some things are going to be small, some things are going to be large. As long as the work of tomorrow looks similar, not identical, but similar to the work of yesterday, it doesn't matter. Yeah, but we have pineapples. Did we have pineapples before? Yep. Are we going to have pineapples in the future? Yep. All right, well, that's the end of that argument. But some of them are small, like grapes. Did we have grapes earlier? Yep. Do we have grapes in the future? Yep. Okay, that's the end of that argument. Now, if the work changes significantly, or if the team changes significantly, we can no longer use our historical data for this. But as long as the team stays roughly the same, ideally the same, and as long as the work stays roughly the same. Like, for example, if I was now to say, instead of a fruit salad, I want to make a vegetable platter. On my vegetable platter, I'm going to want cucumbers and carrots and peppers. Is that close enough? Do you think that we could probably use this? Probably. What if I now told you we're going to turn into a meat restaurant and we're going to do steak and lamb and pork chops, and because there are vegetarians, we're going to do tofu? That's a whole different domain. That's a whole different thing. Our throughput, our numbers that we have from our fruit or our vegetables probably don't apply to meat. It's a completely different type of work. But as long as the work of tomorrow looks similar to the work of yesterday, I can just count the pieces of fruit. I don't need to do anything more. But there's a problem with this. As good as this is, and believe me, this is good. You can save yourself so much time and energy. Get a data baseline, and then you can just do some very simple math. What's your average throughput? But there's a problem with this one. Anyone know what the problem with this one is? Yeah.
You can feed your guests after 10 minutes.
So
You have a fruit salad. You can just bring it out.
You could.
Continually bring out more and more fruit.
So the question was explicit.
Feed your guests.
The question was when will my total fruit salad be done? But you're absolutely right.
Feed your guests. But anyways, you feed your guests.
You're absolutely right, and that was the point 3-4 slides ago when we looked at you can start feeding the guests so much sooner if you want to. Doesn't mean you have to, and that's important to remember. But you're absolutely right. Yes, sir.
Jeff, so question is, where does dependencies fit in here?
Did you have dependencies in the first 3 iterations? Are you going to have dependencies in the next few iterations? The answer is they're the same. That doesn't change because the work of tomorrow looks like the work of yesterday. Now, if we introduce coconuts, for example, and there's a dependency because there's only one person in our entire team who can do coconuts and he's really busy on another project, we've introduced a new type of work. We've introduced a new dependency. We've introduced something that is new. But the dependencies that existed in my first 3 iterations still exist in my 4th, 5th, and 6th iteration. Those dependencies haven't gone away unless I've done something to change it.
So what if, for an example, there's a different team that actually delivers maybe mangoes or bananas,
Yep.
and for some reason they didn't deliver it, that then becomes a dependency?
Yes. So the question is, what if there's another team that I'm dependent on for mangoes? And you're absolutely right. That's not part of this scope whatsoever. That's not part of this project whatsoever. But the moment I introduce another dependency, I've now got another variable to take into account. You'll notice that I'm not talking about dependencies here. Dependencies are a completely separate topic. And if you want to invite me back, I'm happy to talk about dependencies, dependency management, and how to do that. And I'll actually give you a fantastic resource at the end specifically about dependencies. But you'll notice here that the team is able to deliver this fruit salad. And that's what we're focused on, the team delivering here. If there's a dependency in the past, or if there's a specialist that's available who can only do work on the grapes, that may change something. We're going to pull the grape specialist off, and no one else can work on grapes. All right, well, that's a problem. Now we've had 3 iterations to get other people able to work on grapes. Why haven't we done that? So we may want to do that. Listen, this is a way oversimplified example. We're building a fruit salad, for goodness sake. We are not building creative software with multi-team. And by the way, one of the biggest answers that I have for dependencies is, why do you have that dependency and what can you do to get rid of it? And the biggest challenge I find in organizations with dependencies is that they don't want to do that, right? But so we've eliminated that in this stupid, fictitious, overly simplified example of building a fruit salad because we don't have a mango expert who can only work on mangoes, who we are dependent on for that. But the answer would be the same. If that person can't deliver, if that person isn't available, then that's going to change. But we're focused on our team, and our team can deliver this fruit salad in this overly simplified example. The problem that we have with this example that we've used here, and I did it on purpose, is that the numbers worked out really, really well. And that's that we were able to use the average. We used 30 points, 30 or 12 fruit per sprint to get to that 80 to 90 minutes. And there's a problem with averages. Let's do the third activity on the sheet there. Imagine I've got a single D6. Remember, a D6 is a die that has the numbers 1 to 6 on it. So really quickly, and we don't have to do this at the table, we can just talk about this. What are the odds that you're going to roll a 1 on a D6? 1 out of 6. It's not a trick question. Right, 1 out of 6. What are the odds you're going to roll a 6? 1 out of 6. This is good. What are the odds you're going to roll any one specific number? 1 out of 6. This is so easy. Okay, what are the odds you're going to roll an odd number? Okay, hold on. I heard a few different things here. It's not 1 out of 6 for an odd number. How many odd numbers are there on a D6? And how many numbers are there on a D6? 6. So 3 out of 6? Or 1 out of 2? Right. Okay, I heard a few different answers there. Wanted to make sure we got that one right. What about rolling a number above average on a D6? What's the average on a D6? 3.5. 3.5. So what are the odds I'm going to roll over that? 1 out of 2. It's 50%, right? Because an above average number would be 4, 5, and 6. A below average number would be 1, 2, and 3. So it's still a 50-50 chance. 50 chance I'm going to roll over, 50% chance I'm going to roll under. Averages are funny that way. How about the last two? What are the odds I'm going to roll a number above 2? 2 out of 3. What are the numbers that I could roll? 3, 4, 5, 6. And so the last one? 5 out of 6. By the way, I had the answers here, and I meant to push the clicker button, but you're absolutely right. 1 out of 6, 1 out of 6, 3 out of 6, and you'll see the numbers are highlighted, 1, 3, and 5, 4, 5, and 6, 1, 2, and 3, 3, 4, 5, 6, and 2, 3, 4, 5, 6. So here's the thing about averages, is that an average is a coin toss. An average is 50-50. Half of the time you're going to be right and over. Half of the time you're going to be right but under. That's how averages work. Half of the time you're over and half of the time you're under. That's the whole idea about averages. So here, I actually pulled some team data. And this shows the number of stories, not points, the actual number of stories that the team completed in a number of sprints, starting from sprint 30, and we went to sprint 40 here. And what I've done is I've drawn the average for the previous 6 sprints on here. That's that blue line here. But I'm going to focus on these last 6. Weird I picked the number 6. I think it's weird. And when we look at the average number of stories that have been completed over the last 6 sprints, we find out that the average is 26. This team has completed, on average, 26 stories per sprint for the last 6 sprints. Here's the thing. That's their average of 26. Half of the time, they delivered more than their average. Half of the time, they delivered less than the average. In one case, significantly less. So if you were to predict how many stories this team will complete in their next sprint, what would you guess? 26. That would be a very common answer. Yep, team is still consistent. Nothing has changed. The work has not changed. Nothing has changed on the team.
Would I take number 1 out of the equation because it's it's not outline. Can I take that out of the equation and just concentrate only?
You are welcome to ignore any previous data that you don't think is relevant. I, however, think it's relevant because that's actually what the team did. There are reasons for it too, by the way, as to why this team produced that low. So you could decide to eliminate a type of work if it was a different type of work. For example, maybe the team spent that entire sprint paying down technical debt and didn't bother to do any new work. Maybe. But that's not what happened. The team ran into some dependencies. They ran into some challenges in their work. And so that is a totally valid answer for this team. So looking at the dice that we used just a minute ago, do we want to use the average of 50-50? Remember that 50-50 is a coin toss. 26, if we say they're going to probably do 26 next sprint, we may be right, we may be wrong. But there's a 50-50 chance we're going to be right, that they'll do more than that, and 50% chance they're going to do less than that. Who wants to take those odds? If you were to go to your president of your company or your CIO or your director of IT and say, I am going to stand up here and say, we will do 26 points next sprint or 26 stories next sprint. Are you willing to take a 50-50 chance? I'm not. Luckily, we can use the same logic that we used with our dice. We did 36 product backlog items, 36 stories once. We did 33 or more twice. We did 31 3 times, 31 or more 3 times. That last example down at the bottom there, we did 10. We did 10 product backlog items, and we've done 10 every single iteration for the last 6 iterations. So looking at this, I can now have a conversation with somebody and I can say, how risky do you want us to be? Because 50-50, there is a 50% chance that we will do 26 or more. 50% chance that we were going to do that. There is, however, an 80% chance that we are going to do 20 or more. So if you were to ask me what is likely for this team to work, I would say there is an 80% chance that we will do 20 or more items in the next sprint. Those are odds that I would be willing to go and stand in front of my director, my vice president, and say, I'm pretty confident that we'll do 20 or more. Now, an interesting thing that happens, and let me just, before I go on, let me talk about gaming dice for just another second. You remember I said that gaming dice have different numbers on them, 1, 2, 3, 4, 5, 6, and there's ones that go from 1 to 8, 1 to 10, 1 to 12. When your vice president, when your director of IT, when your manager says, I want your team to go faster, my question is going to be, cool, what are you going to do to eliminate the ones from my dice? What are you going to do to give me a D8 instead of a D6 so that I can roll an 8? It's not the team. We don't yell at the dice. The dice only go up to 6. Roll a higher number. I only go up to 6. What do you want me to do? Your team has a capacity as well. Your team has an ability. What are you going to do to enable the system to reduce dependencies, to do things to enable the team to deliver more so that they can roll an 8? I guarantee you that that team wants to roll an 8 if they can. But there are things that are preventing them from doing it. Maybe they need to go on training. Maybe they don't know how to use this new fancy language called Java. I mean, what's wrong with Python? That opens a whole can of worms. What do you mean it's faster for me to use a tab than spaces? Whatever the argument is going to be, whatever that argument is, what can you do to change the system or change the environment? You want the team to roll higher numbers? Cool. What are you going to do about it? Because now we've got the ability with what we know of the team's performance right now that 5 out of 6 times they are going to roll a 5, a 4, a 3, a 2, or a 1. I did that one backwards. A 2, 3, 4, 5, or 6. They're not going to roll a 1 here. There's only one chance they're going to roll a 1. So the odds are 80% in their favor of doing 20 or more based on what they've done in the past. Does it guarantee that they're going to do more than 20? No. I don't know what they're going to do. I don't know that if they're going to encounter another crazy dependency or another crazy thing like what happened here in Sprint 40 or whatever it is, 39, when they delivered 10 items. But I know that there's an 80% chance that they're going to do 20 or more. So instead of working on averages, I want to work on probabilities based on historical data to help me forecast when something is going to be done. Let me try and put this another way. When we do normal math, we take the amount of work and we divide it by the rate at which we do work. So in this case, if we did 25 items at 5 items on average, we would forecast that we're going to complete this in 5 weeks. But in probabilistic math, this is not normal math. In probabilistic math, what we do is we take the amount of work and we divide it by the rate at which we do work, but the rate at which we do work is a range. It's not a single number. If anyone wants this slide, by the way, I'm going to give you a link at the end. This has been totally stolen from a gentleman by the name of Troy McGinnis. The guy is brilliant, the guy is fantastic, and he's going to give away a free tool that I'm going to give you all a link to at the end of this. But you insert your data down here as to what your range of throughput is. It's not a single number. Your team does not work at the same pace every single day. We have good days and we have bad days. So why does this work? Well, here we go. Here is a team that has been delivering for a number of sprints, and this is how much they've actually completed. If we were to look at the total amount of scope that was done, and let's assume that the scope doesn't change for the rest of this project. We have locked down the scope. It is not going to change. We can forecast out using averages when this work is going to be done. In this case, if our scope doesn't change, we can forecast out that our work will be completed right here. Whatever date this is, this would be a date down here. That's the date that our work is going to be done. Here's the problem with this linear projection, is that we might roll a 1, and then we might roll another 1, and then we might roll another 1 all the way through. And the team has some rough times. They have some dependencies that they didn't count on. They have some work that they didn't expect. They have some problems getting their code to work the way they thought it was going to. It doesn't go the way it does on paper. And it takes them quite a while to get it done. Conversely, the team has a really good day. Everything goes according to plan, because we've all worked on those projects, right? Where everything goes according to plan. And the team does really good. They do really, really well. And we find out that actually, if everything goes really, really well, we're going to be way ahead of schedule in delivering it. This is our best case and our worst case scenarios based on the data we've got going on here. And a question we might have is if it's going to be that bad, maybe we should actually cancel the project. The reality is that when we actually do the work, we're going to have some good days and some bad days. And so it's going to end up here in the middle. And then we're going to have some more good days and bad days, and it could look something like this. It can happen over and over again, and this type of a forecasting is called a Monte Carlo forecasting, and what we develop over a period of time is we get a histogram like this that shows us what's the likelihood of hitting a certain date. And then, if you were to ask me, when do I want to forecast something out? Because I'm not much of a betting man, I tend to go around the 80 or 85% mark. And at 80 and 85%, I would predict that this project will be probably completed here. And what that 85th percentile represents is that of all those orange lines, all of those variables, 85% of them happen to the left. They happen earlier than that. So there's an 85% chance we're going to deliver by that date. Doesn't guarantee it, but there's an 85% chance we will. Let me give you a real world example of this. 3 years ago, some event happened and forced us all online. I was getting frustrated at the company I was at because of the amount of time it took me to get onto WebEx. It was exhausting. It was horrible. WebEx has gotten better, not much, but it's gotten better. And so I actually did a little bit of a thing here where I counted how many seconds does it take me to connect to WebEx. And what I did is I counted the number of times it took me 10 seconds or less to get onto a WebEx meeting. 66 meetings I did this for. I did this over a week. I attended 66 meetings in a week. And I got onto WebEx, I don't know, about 2 or 3 times in under 10 seconds. Woohoo! That was impressive. Whole pile of times it was 20 seconds or less. A few times it was 30 seconds or less. 40 started to be a little bit fewer, but there were times that it took me 40 seconds or less. But there were actually times that it took me 50, 60, 70, and even over 100 seconds in order to get onto WebEx. One of those outliers, which this scale doesn't show, is that it took me 14 minutes to connect to a WebEx, because my computer decided that was the right time to do a software update. But it doesn't matter. Like, this is the real world data. This is not Jeff making stuff up. This is me actually tracking how long it was going to. Our average time for me to get onto a WebEx call was 24 seconds. If I take all the amount of time I spent divided by the 66, it was 24 seconds. So if I had an important meeting, would I allow 24 seconds to get on that meeting knowing there's a 50-50 chance? And yet when we look at averages, this is what we do. We take an average and we're like, 24 seconds to get onto WebEx. Yeah, but the problem is that that's not true. There's a great book, by the way, called The Flaw of Averages. Great book if you're interested in looking at the flaw of averages. But the real number for me is that if I was going to count on getting online in 20 seconds, there's actually only a 40% chance that I'm going to do it in 20 seconds or less. At 85%, there's a 50 seconds is where there's an 80% chance, 85% chance. And for those really important meetings, I'm going to allow a minute 10. 70 seconds gives me a 97% likelihood that I'm going to be on that meeting when my boss arrives. And so for the really important meetings, I'm going to do that. And the same thing is absolutely true. So let me go back to my fruit salad for just a second here. Imagine instead of completing 12 pieces of fruit every sprint, we changed the throughput to look like this. And we've got a whole pile of different data. Don't worry, I'm not going to make you do the math here. But if we take the average, we would find that I've completed 57 pieces of fruit divided by 5 iterations, means that I'm completing, I should complete this in 11. In 11. Sorry, that my average is 11. Sorry, guys. I've completed 57 pieces of fruit over 5 sprints, which gives me an average of 11. If I look at the remaining scope is about 49 pieces of fruit. 49 divided by the average of 11 means it's probably going to take me 5 more iterations to do it. But we've only completed 5 pieces of fruit. Sorry, we've only completed 11 pieces of fruit 60% of the time, 3 out of 5 times. Twice in the last 5 iterations, I've done less than that. So my level of confidence is actually pretty low. So how do I overcome this? How do I actually use this data? How do I use that forecasting that we just saw, that probabilistic forecasting where we have good days and bad days? And this is where I want to go back to the great work of Troy. If you don't have this spreadsheet, this is one of the best things. Now, before I talk about this spreadsheet assumes that we are delivering value in each of our product backlog items. If your product backlog item is add something to a database table, that is not something that delivers value to an end user on its own. We have to enable that field on the front end. So the idea here is that when something is going to be done is based on the value that we've delivered. And the way this spreadsheet works, which is free, he makes this totally free and available, is you enter in a little bit of data. You start by the date. So in this case, we're going to start today. You enter in how much scope you believe is in your backlog right now. In this case, it's 49 pieces. So I put in a range of 45 to 50 because that might change. 45 to 50 is a reasonable number, though. It's better if you can use ranges in here. Sometimes when you are working in your backlog, not so much on a fruit salad, but when you are working in your backlog, as you are working on things, you will find that you end up splitting them into multiple items. So this spreadsheet actually accounts for that. It actually says every time you work on something, you might find 2 new things to work on. No problem. You can put that in your split rate in here, and you can put in your iteration length, in this case, 1 week. I'm going to use the data here. And in the data, there's another tab on this spreadsheet where I actually enter in my throughput examples. So how many pieces of fruit did I complete in the last 5 iterations? Well, they were 4, 6, 12, 13, and 22. They don't need to be sorted in any order. You can put them in any number that you want. The spreadsheet gives you 2 other things. It's how well understood is your backlog? Are you early on in the project, or are you later on when you know everything or you think you know everything? And you can actually, this will change the variability of what the output's going to be. You can also put a focus on how much is my team focused on this work? Are we fully dedicated to this, or are we working on 3 other things as well? This spreadsheet then goes and runs 5,000 samples in the background. These are the first, 500 samples in the background. This is only the first 50. And you can see that my scope starts with somewhere between 45 to 50. That's because that's what I put on the spreadsheet. And it burns down a number by rolling dice effectively. And sometimes it rolls a 1 and sometimes it rolls a 6. And it figures out what is the likelihood of hitting a certain date. I don't need to know any of the math behind this because it gives it to me in a beautiful little table like this. And it shows me right up here that there is an 85% chance, there it is, that bottom green one, that I will deliver it in 6 more iterations by this date. Now, if you want, you can take a 50-50 guess. You can go 50-50. And in this case, it also happens to be a 5 because the numbers are so small. But it will actually do this forecasting for you. Phenomenal tool, totally available for free. Let me tell you an example, give you one quick story about where I use this. I was working with a team at a large bank in the US. The team had delivered a module in October of 2021. They had started to move on to their next module set to be released in March. I got involved with the team in January. I was only brought in to help them out in January. In January, I started looking at their backlog of things that they were going to do, and I really suspected that there was a good chance they weren't going to deliver this on time. Having a look at it, I'm like, not so sure this is true. Now, the work of the previous module was similar enough to the work of the new module that they were building that I was able to look at their forecast data. And I forecast that they would complete it in September. They wanted to complete it in March, and I'm looking at it and I'm thinking, I'm pretty sure it's going to be September. I was told I was wrong. I was wrong. Everyone told me I was wrong. I did not make a lot of friends when I started to say, hey, I'm not sure we're going to hit this date, guys. It's looking like September, if you ask me. The team didn't like me. But come February, they realized they weren't going to be ready for March. So they told everybody that they were going to get it done for April. 100% sure, they were positive for it. By the way, this was the engagement where I actually at one point, probably in February, it could have been March, I said to the product owner, who by the way had no idea, they couldn't get a sprint right. Like they would commit to 22 things and they would deliver 12. And I actually had to say to him at one point, Tom, because that was his name, I said, Tom, you haven't been able to predict what you're going to get right in a sprint. What on earth makes you think you can predict when you're going to have a release ready? And I didn't know how that was going to go over. There was dead silence. We were on a WebEx call. He didn't have his camera on. And a few seconds went by and I'm like, oh, shoot, what have I done? Guess I better start looking for a new job. And he said, Jeff, you are absolutely right. Can you help me out? It did come up a little bit later. I'm a little bit ahead of it here. But I still think it's going to be September, maybe early October, based on the numbers that are going on. I am so not popular with everyone, and I'm being told by everybody that they're wrong. At one point, the team was so mad at me, they said, oh yeah, Jeff, just watch us. And the next sprint, I think they did something like 28 things. Like they tripled their throughput. They tripled what they did. And I said, cool. Is this sustainable? And they said, no. I said, why not? Well, we all worked all this overtime, and we called in all this. And I'm like, oh, God. Guys, you don't have to prove me wrong. By March, they realized they weren't going to hit April, but they were going to hit May for sure. So in April, they came to me and they finally said, hey, we need your help going on. And I think it was at this point I said to Tom, dude, we need to talk. We went through some numbers. We determined that September was still very likely, maybe early October. They ended up communicating that throughout the organization, and absolutely nobody was happy with this team. Not a single person was happy with the team. However, the end of the story is that they delivered the second week of September. By the time they fixed all of the defects and bugs that had made it through, they actually had everything working by the end of September. The fourth week of September, they managed to get everything done. Was it that I had a crystal ball or some magic? No, I just used their throughput. I used their data. And even though the work they were doing was different, it was similar enough to the work that they had been doing that the data still held through. So let me leave you with a few thoughts by Jeff Kosciejew. Here we go. We are really good at comparing things. We are great at comparing two different things and saying which is bigger, which is harder, which is riskier. We are not good at estimating, so maybe we should stop trying to estimate and instead we should get better at comparing. When we do this sort of comparison, they're for the team and for the team only. They're for us to come up with a shared understanding so that we can actually have a meaningful conversation on how we should be working on things. Nobody should be reporting these. Nobody should be reporting on these at all. This is for us as a team to have a meaningful conversation. Averages can be incredibly dangerous. Averages are a 50-50 coin toss. We can use probabilistic forecasting effortlessly and easily to help us get more likely forecasts, and we can estimate those forecasts on a regular basis. If your team happens to follow Scrum, you can update your forecast at every sprint review. If your team happens to follow Kanban and you follow the LKU model, you have a service delivery review. You can update your forecasts at that time if you need to. You can do it at other times too. There's no one that says you can't. But these are a couple of parting thoughts. I promised you some resources. We're going to make sure that these links are available in the meetup. First of all, you might want a fruit salad recipe. I've provided one for you. Secondly, you may want to sing the fruit salad song by the Wiggles. I provided a YouTube link for the fruit salad song by the Wiggles. Yummy, yummy. The forecasting spreadsheet you can get from a bit.ly link. It's bit.ly/throughput forecaster. It is case sensitive, and that's from Troy. I've also given you some other work from Troy because I want to promote his stuff because I have learned so much from him and applied it to the teams and organizations that I've been involved with that I use so much of this stuff on a regular basis. And almost all of his stuff, by the way, is free. He does offer workshops as well, but most of his stuff is free, and most of his Excel spreadsheets are done without macros, so you can usually download them even if you're behind some sort of corporate firewall. Not always, there have been some exceptions, but you can usually get to it because he's made sure to try and make it as available as much as possible. I'm going to stop talking now unless people have questions, comments, concerns, or compliments. But I want to say thank you so much for hosting us. Thank you. Really appreciate being here. To the Agile TO organizing committee, thanks so much for inviting me. Thank you for coming and participating. I hope you found something a little bit useful out of this. And if you want to talk more to me at any point, you can find me at agilemagic.ca or LinkedIn or Twitter or any million of other places. By all means, please reach out to me anytime. I love talking about this stuff. Happy to have a chat if anyone wants to tonight. Otherwise, I understand drinks are happening. Grace O'Malley's. Excellent. Thanks, everyone. What time is it, John? I was given a time and told to end by 7:50.
Thanks everyone for coming. I appreciate that. Yeah, great presentation.
No problem.
Really
Thank you.
enjoy it. Make sure this building is secure. So if you need to leave the building, you have to be accompanied by one of us because we have to batch you. And then we have few volunteers. There's plenty of pizza, please serve yourself. And then otherwise, I'll see you guys later on the park. Okay.
Awesome. Thank you so
No,
much.
thank you.
Yeah, no, any questions, any comments, any thoughts? Yeah.
Questions. Are you familiar with Vasco transport?
With
Vasco trans.
Yep.
Work around no estimation.
Yep. If in fact, if you look up a lot of Vasco's work, you'll see my name show up a number of times.
Right. So the question then is, stakeholders want to see estimation, right?
No, they don't want to see estimations. They want to see forecasts. And that's part of this talk, is that estimation and forecasting are two separate things. They serve two different purposes. Estimations, they don't care about estimations. They want to know, when is it going to be done? How much effort is it going to be? Does it meet my internal rate of return? Does it meet our internal hurdle rate? Does it give me ROI? That's what they care about. They don't care whether something's a 3 or a 5.
So obviously then forecasting then means that we use the available data from maybe